Good day, guys. This is your tutor engineer. Today we'll be doing an exam question of grade 12. The topic will be electrostatics. So let's start. Two small identical spheres P and T are placed at a distance 0,2 meters apart as shown in the diagram below. P carries a charge of positive 3 times 10 exponent minus 6 coulomb and T a charge of minus 3 times 10 exponent minus 6 coulomb. The first question is state Coulomb's law in weights. So Coulomb's law is based on this formula here. F is equal to K times Q1 times Q2 divided by R squared. So it basically says the force between two charges, in this case P and T, is directly proportional to the product of their charges and inversely proportional to a square of a distance between them, which in this case is 0,1 meters. Then the second question, 7.1.2, draw the resultant electric field pattern due to the charges on point P and T. So since point P is the positive charge and point T is negative charge, so that means the resultant, the electric field, will move from point P, which is the positive charge, to the negative charge. So it's going to be doing something like this. And then here you can draw a straight line as well. So from the positive charge, it points outwards, and then from the negative charge, it goes inwards like that, the arrows. So that's how it's going to be looking like. Now let's go on to the next part of the question. A third charge sphere S of unknown charge QS is placed at a distance of 0,515 meters from sphere T. Here is QS, such that the three charge spheres are at the vertices of a right angle triangle. The net electrostatic force on sphere T due to the other two charge spheres has a magnitude of 10 Newton. So this is the F net, or the resultant force, is 10 Newton. 7.1.3 is charge QS positive or negative. So you can see the force is pointing into that direction. It has a horizontal element in this direction. So it means here charge T, which is negative charge, is attracted to charge S. So charge S would be in a positive charge for it to be attracted. So the answer here would be positive. And then 7.1.4 calculates the number of electrons added to or removed from charge from sphere S to give it a charge of QS. What we're going to be calculating, we'll be calculating the charge itself to calculate the number of electrons. So once you get the QS, we'll divide it by the QE, which is the charge of the electrons. That is given on the formula sheet as 1,6 times 10 exponent minus 19 coulombs. But firstly, we need to calculate the QS. Okay, now let's start there. So the first thing we will do here, looking at this question, we have the net force of 10 Newton. So we'll calculate this force here, the force of attraction between T and S. Let's call it TS. And then we'll calculate the other force of attraction between P and T. So let's call it F, let's call it TP. So now, starting with FTP, the formula is K QT QP over R squared. K is 9 times 10 exponent 9. QT is 3. You don't need to put a negative sign at this point in time. So just write it as positive. 10 exponent minus 6, and also charge at P, write it as positive. Then the distance between P and T is 0,1. So write 0,1 here, squared. So if I can use a calculator, 9 times 10 exponent 9 times 3 times 10 exponent minus 6 times 3 times 10 exponent minus 6. Then divide all of that by 0,1 squared. That gives me 8,1 Newton. It's up. That's why I said you don't need to write a negative sign. You just have to write this direction. You know that this resultant force has got a vertical element pointing upwards, so the direction of the force would be up. We'll do the same thing for FTS. Let's write it this side, FTS, KT, then Q, S divided by R squared. The K remains the same all the time, 9 times 10 exponent 9. Then QT is 3 times 10 exponent minus 6, kind of running out of space. And then QS, I don't know, that's what I want to find out. Then the distance between T and S with 0,15, so 0,15, you'll square it. Then I'm going to multiply 9 times 10 exponent 9 multiplied by 3 times 10 exponent minus 6. All of that divided by 0,15 squared. So here I'm getting, let's see, I'm getting 1,2 times 10 exponent 6 QS. Obviously this will be going to the right, or I can say east. That's the eastern direction. Now that I've got these two forces, I can reconcile it to the resultant force. The resultant force is 10 Newton. Or I can rewrite the forces in terms of the head to tail method. This FTP will be going up by 8,1 Newton. And then FTS will be going to the east by 1,2 times 10 exponent 6 QS. Then I have the resultant force, which is 10 Newton. So this is a triangle, a right angle triangle. I can use the theorem of Pythagoras to work out the QS. So according to the theorem of Pythagoras, is the hypotenuse side squared is equal to this side here, adjacent side, 8,1 squared plus that other side, 1,2 times 10 exponent 6 QS squared. Then here 10 squared is 100, 8,1 squared gives me 65,61. Then 1,2 times 10 exponent minus 6 squared will give me 1,44 times 10 exponent 12 QS squared. Don't forget to square the QS. So now let's just do some maths. 100 minus 65. The 100 will stay on the left hand side, then the 65 will become negative. That's equal to 1,44 times 10 exponent 12 QS squared. So 100 minus 65,61 gives me 34,39. Then I'll maintain 1,44 times 10 exponent 12 QS squared. Then I can divide by 1,44 times 10 exponent 12 both sides. And then I'll find QS squared equal to So this is the QS squared. It's 388, 2,388 times 10 exponent minus 11. So if I put a square root both sides, I'll get the QS equals to, it's 4,886 times 10 exponent 6 coulombs. So that will be exponent minus 6 coulombs. Remember, we have to assign it a sign. We decided that the sign is positive, so that 4,866 is going to be a positive 4,866 times 10 exponent minus 6 coulombs. So now when it comes to calculating the number of electrons, we'll use this formula. Now that you know QS, it's 4,886 times 10 exponent minus 6. We divide it by 1,6 times 10 exponent minus 19. That will give us the number of electrons to be 3,05 times 10 exponent 13 electrons. So that's it. If you like this this lesson, please hit the like button and consider subscribing.